This is SpaceTime, Series 28, Episode 88, for broadcast on the 23rd of July, 2025. Coming up on SpaceTime, a new study has confirmed that human development has now caused planet Earth's poles to shift. Discovery of a world beyond Pluto, which may put an end to hopes of ever finding a Planet 9. And Japan's Martian moon sample return mission set to launch next year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that human development has now shifted the centre of gravity of the Earth so much it's actually caused the planet's spin axis to shift. The findings, reported in the journal Geophysical Research Letters, indicates that over the past 2 centuries, humans have locked up so much water in dams so as to shift Earth's poles slightly away from the planet's original axis of rotation. The study shows the construction of nearly 7,000 dams between 1835 and 2011 shifted the poles by about a metre in total and caused a 21mm drop in global sea levels. Now, while this shift is small, it will help scientists better understand how the poles will move as major glaciers and ice sheets melt as a result of climate change. The Earth's outermost solid layer, the crust, actually sits on a viscous layer of molten rock, allowing it to move relative to the magma below it. Now, any time mass is redistributed around a planet's surface, such as when ice sheets grow or shrink, the outermost rock layer wobbles and moves around. Imagine slapping a lump of clay onto one side of a spinning basketball. In order to maintain momentum, the part of the ball with the clay on it will shift slightly towards its equator and away from its axis of rotation. When this same thing happens on planet Earth, the outermost layer of rock wobbles around, and different areas of the surface end up sitting directly over the axis of rotation. It means the geographic poles then pass through different spots on the surface than what they did before. That's a process known as true polar wander. The study's lead author, Natasha Valencic, says that as humans trap water behind dams, not only does it remove water from the oceans, thus leading to a global sea level fall, it also redistributes the planet's mass in a different way around the world. Valencic and colleagues used a global database of dams to map the locations of each dam and the amount of water each impounds. They analysed how the water impoundment from 6,862 dams shifted Earth's poles between 1835 and 2011. Their results showed that global dam building has caused Earth's poles to shift in 2 distinct phases. Between 1835 and 1954, many dams were built in North America and Europe, shifting these areas towards the equator. That caused the North Pole to move 20.5 centimetres towards the 103rd meridian east, which passes through Russia, Mongolia, China and the Indochina Peninsula. But then, between 1954 and 2011, dams were mostly built in East Africa and Asia, and the pole shifted 57 centimetres towards the 117th meridian west, which passes through western North America and the South Pacific. So over the entire period between 1835 and 2011, the poles moved about 113 centimetres, with about 104 centimetres of movement happening in the 20th century alone. The results show that scientists need to take water impoundment into consideration when calculating future sea level rise. In the 20th century, global sea levels rose by 1.2 millimetres per year on average, but humans trapped a quarter of that amount behind dams. Valencic says that depending on where you place the dams and reservoirs, the geometry of the sea level rise will change, and these changes can be large and significant. This is SpaceTime. Still to come, the discovery of a world beyond Pluto, which may put an end to hopes of ever finding a Planet 9. And Japan's new mission to collect samples from the Martian moon Phobos to launch next year. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Incogni. If you're anything like me, you're probably concerned about your privacy online. And for good reason. Did you know there are hundreds of data brokers out there quietly collecting, buying and selling your personal information? Now, I'm talking about your phone number, your home address, your browsing habits, even your location history. And that's where Incogni comes in. Incogni is a service that acts on your behalf, requesting the removal of your personal data from these shady data brokers. And they don't just send a one-off email. They follow up, track responses, and ensure that your data actually does get deleted. Think of it as having a digital privacy agency constantly working for you behind the scenes. And the best part, it's all incredibly easy. You just sign up, give them the go-ahead, and Incogni take care of all the rest. And within just a few weeks, you'll start seeing the results. There'll be fewer spam calls, less targeted advertising, and a genuine sense of relief knowing that your private data is no longer being traded like a commodity. Now, as a SpaceTime listener, we're offering you a special discount deal. Just go to incogni.com/StuartGary. That's incogni.com/StuartGary. And if you're not completely satisfied, no worries. Incogni offers a 30-day money-back guarantee, so you can try it out risk-free. You know, protecting your privacy really shouldn't be optional in this digital age. So let Incogni help you by keeping your personal information where it belongs, with you. That's incogni.com/StuartGary to access this exclusive discount offer and learn more. Stay safe, stay private with Incogni. And now it's back to our show. Astronomers have discovered a small celestial body in the outer solar system beyond Pluto, which may put an end to any hopes of ever finding a Planet 9. The findings, reported in the journal Nature Astronomy, could have significant implications for the formation, evolution and current structure of this dark and distant region of space. The newly discovered object, which has been designated 2023 KQ-14, was found as part of the formation of the Outer Solar System, an Icy Legacy fossil survey project using the Subaru telescope in Hawaii. The object was initially detected back in March, May and August of 2023. Then follow-up observations in July last year with the Canada-France-Hawaii telescope confirmed the earlier discovery. Astronomers then examined archival data from other observatories, and that allowed them to track the object's orbit over 19 years. Now, due to its peculiar distant orbit, 2023 KQ-14 has been classified as a sedenoid, making it only the fourth known example of this rare type of object. Sedenoids are named after the first of these objects to be found, dwarf planet Sedna. Numerical simulations indicate that 2023 KQ-14 has maintained a stable orbit for at least the last 4.5 billion years. Although its current orbit differs from those of other sedenoids, the simulations suggested their orbits were all remarkably similar around 4.2 billion years ago. The fact that 2023 KQ-14 now follows an orbit different from that of the other sedenoids suggests the outer solar system is far more diverse and complex than previously thought. The discovery also places new constraints on the hypothetical and long sought-after Planet 9. See, if Planet 9 does exist, then its orbit must lie much further out than what's typically been predicted. The study's lead author, Yukan Huyang from the National Astronomical Observatory of Japan, who conducted the simulations of the orbit, says the fact that 2023 KQ-14's current orbit does not align with those of the other three known sedenoids lowers the likelihood of the Planet 9 hypothesis. You see, 2023 KQ-14 was found in a region of space far away where Neptune's gravity has little influence. The presence of objects with elongated orbits and large perihelion distances in this area implies that something extraordinary must have happened during the ancient era when 2023 KQ-14 first formed. So understanding the orbital evolution and physical properties of these unique distant worlds is crucial for comprehending the full history of our solar system. This is SpaceTime. Still to come, Japan preparing for next year's launch of its Martian moon Phobos sample return mission. And later in the science report, a new study warns that most crops will be affected by climate change. All that and more still to come on SpaceTime. Japan's aerospace exploration agency JAXA will launch its sample return mission to the Martian moon Phobos next year. The Martian Moon's Exploration, or MMX mission, is a robotic spacecraft designed to land and collect samples from the largest of the red planet's two moons. The probe will also undertake a close flyby of the other Martian moon Deimos, and it will monitor the planet's climate. The mission aims to provide key information designed to determine whether the Martian moons are captured asteroids or the result of a larger body slamming into the red planet. After launching aboard Japan's H-3 rocket from the Tanegashima Space Center, the spacecraft will enter orbit around Mars and then transfer to Phobos and land once or twice, gathering sound like regolith particles using a simple pneumatic system. The lander mission aims to retrieve at least 10 grams of material. The spacecraft will then take off from Phobos and make several flybys of the smaller moon Deimos before sending its sample return module back to Earth, arriving here in 2031. The total launch mass of the spacecraft will be 4,000 kilograms. That includes 1,900 kilograms of propellant. The mission architecture will use 3 modules. There's an 1,800 kilogram propulsion module, a 150 kilogram exploration module, and a 1,020 kilogram return module. With the mass of the moons Deimos and Phobos being too small to capture a satellite, it's not possible to orbit the Martian moons in the usual way. However, orbits of a special kind, referred to as quasi-satellite orbits, can be sufficiently stable to allow many months of operations in the vicinity of the moons. MMX will carry 7 primary scientific instruments. There's a narrow-field camera for a detailed terrain survey, an optical radiometer using wide-field visible light chromatic images, a LiDAR light detection and ranging laser to reflect light from the moon's surface in order to study the surface altitude and albedo. There's a near-infrared spectrometer which will characterise the minerals and composition which make up the moon's surface, as well as a gamma-ray and neutron spectrometer, a circum-Martian dust monitor to characterise the environments around the 2 Martian moons, and a mass spectrometer analyzer to study the ion environment around Mars. Science writer Jonathan Nally says there are many mysteries surrounding the red planet's 2 moons and their origins, which this mission will seek to resolve.
Scientists are still trying to figure out how Mars came to acquire its 2 small potato-shaped moons called Phobos and Deimos. And these are tiny moons. They're nothing like our moon. They're just really, really small. Phobos has a as I say, it's potato shaped, so it doesn't have a one particular dimension, but its average width is about 11 kilometres, which is about 7 miles. Deimos is even smaller. It's only about 6 kilometres wide, so it's about 3 miles across or so. So they are really, really tiny, and they're the only moons that Mars has, and they just trundle around the planet, minding their own business. Phobos is interesting because it's actually losing altitude as each day goes by. It's about 2 centimetres per year. It's drifting closer and closer to Mars. So they reckon in about 20, 30, 40 million years or so, it's either going to crash into the planet or be torn apart by tidal forces when it gets too close. No one's really sure yet what's going to happen.
One ring to rule them all.
Ring to rule them all, yeah. Well, we'll come to that because no one is sure yet how they came to be orbiting Mars. All sorts of hypotheses have been proposed over the years, but there are a couple that are currently in vogue with scientists. One has it that a large rocky body of some kind crashed into Mars a long time ago, and that spewed rocky debris out into orbit where these 2 moons finally coalesced. And there was probably lots of other debris floating around as well, but that eventually fell back down onto Mars, and then the sort of orbital space above Mars became cleared apart from just these 2 moons. Nothing really controversial about that. That sort of idea has been around for a long time. The other idea, though, is interesting, and it starts with the same sort of collision with some big rocky body crashing into Mars, and that then followed by the formation of lots and lots of moons orbiting around the planet that have formed from the debris that got thrown into orbit. But some of these moons will then eventually break up again due to tidal forces, and then you'll get a smaller number of moons forming out of the debris of them, and you just sort of rinse and repeat, and you end up in the end with just 2 of them. So that's been taken seriously by a lot of people. So that could explain certain characteristics of why Deimos is further out and Phobos is closer in, and how they ended up in their particular orbits, and why Phobos is losing altitude slowly, and yada, yada, yada. So no one really knows for sure yet, but those are the 2 main ideas.
It's a huge ongoing debate, isn't it? We've got all sorts of hypotheses out there. I was reporting just the other week on another 2 options, one involving Phobos and Deimos being formed by a collision between 2 objects in orbit around Mars, and then the other option is they were simply captured asteroids, but their orbits don't justify the captured asteroid story. So
no, a long time ago that used to be the main idea. They just because they look like asteroids, are about the size of asteroids, so they were probably captured asteroids. That was a very common thought, it seems pretty straightforward. An asteroid gets too close, gets captured into orbit. But they're pretty certain now that's just not the case for all sorts of reasons. Some of these mysteries, though, might be solved, or at least, if not solved, we might have a few more bits of information to plug into them later this decade, because Japan's going to be sending a mission there called the Martian Moons Exploration Mission. That's an imaginative title, isn't it? The Martian Moons Exploration Mission. That's going to head to Phobos. It's going to land there, and it's going to take some samples and blast off and bring them back. So that should be pretty specky. The Russians have tried this long time ago.
Phobos Grunt, yes.
Yeah, and they it didn't work. There were a whole string of Mars mission failures back then. I still remember there was another mission called Mars 96 that was sent off, and it got launched, and it didn't get out of Earth orbit. Really, it didn't even make it into Earth orbit much. And I remember this because I woke up early that morning, and
this was a Proton rocket failure, wasn't it?
I think it was. And the word was that this thing was going to come back down to Earth within the next orbit or two, and it might crash into Australia.
Yeah.
And I remember I was doing lots of radio stuff at the time. Did used to do a lot of work with ABC Radio in Sydney, and I rang up the studio and said, "Hey, there's this big story. This Russian thing might be going to crash into Australia, and it's got a bit of plutonium on board and all that sort of thing. So it could be a problem." They said, "Oh, don't bother us with that. We've got really big, important political things going on this morning," and blah blah blah. Well, they phoned me back 20 minutes later and said the Prime Minister's about to have a press conference about this.
Yes.
About this Russian thing coming down.
Yes,
Can you talk to us about it? Yeah. He and John Howard, the Prime Minister at the time, had a press conference about the possibility of this thing crashing into Australia. Mars 96. The good old days when missions to Mars failed all the time.
Sometimes because they simply confused imperial and metric measurements.
Yes, all sorts of reasons. Mars was the first planet that I had identified in the night sky when I was a teenager. It was the first one I learned how to pick out. It was pretty easy because it was red. So I've got a bit of a soft spot for Mars, and that was about 1980. Well, at the time, the Viking missions were still on Mars, and it was the year after that, it was 1981, I think it was, that they switched off one of the Vikings, and a few years after that, 86, I think it was, they switched off the other one. And then there was just a long period of a decade or more where other Mars missions were attempted, but they all failed. And it took until 1997 when the Mars Pathfinder mission eventually got there with this little Sojourner rover, be the next successful mission after the Vikings. So there was a long period there where everything was just going wrong with Mars missions, and a few after Pathfinder as well. But they obviously have learned their lessons because the missions, look at Perseverance, they're doing it really well these days. They know what they're doing.
I remember staring at an image in the school library taken by one of the Viking landers from the surface of Mars, and just looking at that then red landscape with this green sky. That's the way it looked in the newspaper image anyway. And I was just fascinated with it. I
thought you were going to talk about Cydonia and the famous face on Mars.
Oh, that came later.
That came later. Oh, that was a lot
real,
of responses too, wasn't it? The aliens, yeah. People made a lot of money out of that. Anyway.
That's senior science writer Jonathan Alley, and this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that most of the crops we grow are going to experience substantial production losses due to climate change. This will likely still happen even with current mitigation measures in place. The findings, reported in the journal Nature, looked into the future of maize, soybeans, rice, wheat, cassava and sorghum, and have found that only rice might avoid substantial losses. The authors estimate that for every 1 degree Celsius increase in temperatures above pre-industrial levels, production will decline by 120 calories per person per day, the equivalent of about 4.4% of current daily consumption. By the way, in 2024, it was confirmed that global temperatures have already increased by 1.5 degrees above pre-industrial levels. The authors say that under a high emissions scenario, the United States, Eastern China, Central Asia, Southern Africa and the Middle East will lose almost half their maize production by the end of the century. Europe, Africa and South America will lose a quarter of their wheat production, and a third will be lost from China, Russia, the United States and Canada. A new study has shown that adults who have stayed consistently active throughout their lives can lower their risk of early death by up to 40%. The findings, reported in the British Journal of Sports Medicine, examined data from 85 studies covering more than 8 million people. The authors found that lifelong physical activity reduced the risk of premature death, while inactive people who became active later in their life could still lower their risk of premature death by between 20 and 25%. A new study has found that American teens with high and increasingly addictive use of social media appear to have a 2 to 3 times greater risk of suicidal behaviour compared to kids with lower addictive use patterns. The findings, reported in the Journal of the American Medical Association, are based on surveys of more than 4,000 children and teenagers over 4 years, looking at how addictively they use social media, cell phones, and video games. They found addictive use was common. For example, 50% of all teenagers were highly addicted to their cell phones. Until now, research into screen use in mental health had always focused on screen time. But the authors say these new findings suggest that focusing research and interventions on addictive behaviour rather than total screen time may hold more promise. Well, your smartwatch is getting even smarter, with approval by Australia's health regulator, the TGA, of new software which will enable sleep apnea notifications on Apple Watches. Sleep apnea is a huge health problem which can cause high blood pressure, fatigue, type 2 diabetes, strokes, heart attacks and shorten lifespan. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Yeah, well, I first want to start by noting that Samsung, when they launched their Watch 8, and we spoke about this last week, it not only does the heart blood pressure, but they're also launching sleep apnea detection. And, of course, as we spoke about last time, they're able to detect your antioxidant levels of your body by you putting your thumb on the back. So interestingly, a week later, Apple has come out noting that thanks to a big sleep study they've done with 1 million participants and using advanced machine learning, they now can detect sleep apnea. So you get these notifications from today on your Apple Watch. And, it's potentially a serious condition when breathing stops repeatedly during sleep. In Australia, it impacts about more than 1 million people, and it often goes undiagnosed in many cases. And it can have obviously important health consequences. So you've already been able to do this sort of thing with other apps and other devices, but the wearable device, which is increasingly all about health, not just telling the time or being a portable radio or able to make phone calls, but actually able to help you measure your health metrics, is something that's becoming a standard thing, and people are going to be taking it for granted very soon. So this is called breathing disturbances. You get a notification after 30 days that really tracks your sleep for a long period of time. And then, of course, you have the information that you can show your doctor on your phone, and it's been tracked and measured.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.